So last question, question 4. Spearman's rank. The table gives the heights and masses of 5 people. Calculate Spearman's rank correlation coefficient. So we need to put this data into order to start with, so that we can start doing something with it. We've got height and mass. We've got the 5 people. So let's do our new little table where we use the orders instead. So this is the height and the mass. So how did it go? That was the tallest, and then it was that one. That one. There we go. So that would be the first set. Put into order the second set. Let's go from heaviest. So that is 1, 2, 3, 4, and 5. Now in the formula, all we need to know is the value of sigma d squared. That's what we're after. So we want to work out our differences. It doesn't matter which order we subtract these. So let's do 3 take 1, 5 take 4, 1 take 3, 4 take 5, and 2 take 2 would be 0. We need to know about these values squared. It doesn't matter, but I missed a minus sign, didn't I? I'll get away with it, because once I squared it, it doesn't make any difference. But d squared is going to be 41410. So the sum is 10, and then we put it all together. Again, the formula in the formula booklet, let's not mess it up by writing the formula down wrong. So it looks like that. We've got n is 5, isn't it? There were 5 numbers. So it's 1 minus 6 times 10 over 5 times 25 minus 1. And actually it's a really neat calculation that we've just done here, because everything comes together really nicely. You end up doing 1 minus a half, which gives you a half. Your value. It all cancels down, doesn't it? Because you've got 10 over 5, which is 2 on the top, so that's 12 on the top, over 24 on the bottom. So 1 minus a half. There we go, that's it. And they gave you 5 marks for doing that. Again, really easy to mess up, to make a tiny mistake, to get a little numerical error coming in there. But we've got to be really careful. 5 marks is brilliant for that. Now, in an art competition, do you remember how they do this? I think we talked about this when we did Core 2. OCR, I think they pretty much stick to this, have this thing where if it's part 1 and part 2, it means they're connected and they flow through the same kind of question, they're interrelated to each other. If it's part A and B, then it's the same subject area, but a different kind of basic question. So we're not using our previous answer, we're now on part B. In an art competition, the value of Spearman's rank correlation coefficient, RS, calculated from 2 judges' rankings was 0.75. A late entry for the competition was received and both judges ranked this entry lower than all the others. By considering the formula for RS, explain whether the new value of RS will be less than 0.75 or equal to 0.75 or greater than 0.75. Right. So what's happened? We're not allowed to just use our instinct with this. Our instinct actually, I suspect, might be wrong. I don't know what you kind of think, but we got a value of 0.75. These two, they both ranked them lower than the others. They just, there were, how many, didn't say how many there were, was it? But there was a certain number of entries, and then you had this extra one, and it was the last number. So surely it would just be the same, because we just added a number on the bottom of both of the rankings. But if it's not the same, what does your instinct tell you now? They both ranked it last place. So they both agreed. They were agreeing a bit before, but then they're agreeing even more now because they ranked it last place. So I think our instinct now, that we've thought about it a bit, would suggest that RS would be bigger, because they're agreeing more. Does that make sense? Okay, so let's try and think about it in terms of what's actually happened with this information here. Because it did say we had to think it through in terms of sigma d squared and all of that stuff. So let's think about the parts of the formula. N is larger, isn't it? Because we've got an extra item of data in our survey. So if n is larger, n times n squared minus 1 is larger than it was before. So that's the first thing that we've got to establish. The second thing is, let's think about the differences. The differences wouldn't have changed. This last one would still, it would have contributed 0 to sigma d squared. So sigma d squared would remain the same, because the last difference added 0 to it. So what we've just said, remember in the formula we've got this fraction, 6 times sigma d squared over n times n squared minus 1. Now, the top of that fraction has remained the same. The bottom of that fraction has got slightly bigger. What happens if the top of the fraction stays the same but the bottom gets slightly bigger? What can you say about this amount? It would get slightly smaller, wouldn't it? So that would now be smaller. And that, when we calculate RS, we're taking that amount away from 1. So we're taking a smaller amount away from 1. So our instinct was right. If we take a smaller amount away from 1, RS would be greater, because we've taken less away from 1. So it did kind of tally. And that's maths.